and welcome to the 2021 Body Integration Training Overview. This is an exciting time for Peterbilt, Peterbilt dealers, body manufacturers, and most importantly, our customers. My name is Tony Sabler, and I'm the Vocational Marketing Manager at Peterbilt. This training module will provide an excellent opportunity for an overview of vocational body integration with the 2021 VMUX electrical system. Additional training modules will also dig deeper into specific topics so you have the knowledge to be an expert in vocational body integration. Let's get started. In 2018, Peterbilt introduced the VECU, or Vehicle Electronic Control Unit, to the Model 567 and 579, which increased the capacity and processing power of the truck's electrical system. This also further integrated the MX engine with the 567, bringing more flexibility and functionality to the vocational body integration. Now, in 2021, we have expanded those benefits to our other models, including the heavy-duty models 520 and 389, and the new medium-duty models 548, 537, 536, and 535. What are some of the important takeaways I want you to learn? We've already covered the first one, so we're off to a great start. Second, the commonality of a single electrical system instead of multiple systems greatly simplifies body integration. Third, VMUX stands for VECU multiplex, and a completely multiplex system improves reliability and diagnostics capability, maximizing uptime. Next, we focused a tremendous attention on keeping the operator informed so they can be most effective. Peterbilt's VMUX system is customizable to fit each customer's specific application, which leads me to the last and probably the most important point I want you to take away, which is to understand the customer's needs, what they need the truck to do. This will help you spec it correctly, it will lead to better body integration, and ultimately, better performance when the truck is in service. One of the main things that differentiates a vocational truck from others is the presence of a PTO, which integrates the chassis to the body so the overall truck can perform an intended function. There are many different types of PTOs, split shaft, transmission mounted, or an engine takeoff, and each has a specific characteristic and applications for its use. Understanding how the operator will control the PTO is one of the main things you should understand when speccing the truck for body integration. I'll walk through an example of how the PTO is controlled from the cab station of a Peterbilt with a VMUX electrical system. It's a two-step system, including PTO mode control and PTO speed control. First, activate PTO mode control. This can be accomplished several different ways, including pushing the PTO switch to engage a PTO, or in the case of a Repto, which is always engaged, you can press the PTO mode switch on the dash. Another option or method is to send a PTO mode request over the CAN bus. We'll cover this in more detail in other modules. When PTO mode is activated, all the vehicle's protections, limits, and safeties become and remain active. Depending upon the job, the operator will select if they will be controlling the PTO from a cab or remote station. And an icon will appear in the dash display, keeping them informed. You can also track how much time is spent in PTO mode, simplifying fuel tax reporting. Second is to enable speed control. This enables speed control of the engine using switches, body inputs, or CAN messaging. To do this, flip the cruise control switch to the on position. Again, an icon keeps the operator informed. At this point, you have a number of options for how to set the PTO speed. Some of these allow pre-programmed speeds, others permit variable speed control, depending on the application. The requested RPM is shown in the display, reassuring the operator. This is a good overview of PTO operation with a PACCAR MX engine, and it highlights some of the great features to ensure safety and keep the driver informed. Next, we'll take a look at some of the options that are available to properly spec a truck for the job. Let's start with the VMUX connectors that communicate between your Peterbilt chassis and the body. The first major benefit, as I said earlier, relates to the consistency of body integration across Peterbilt's trucks. For those of you that are familiar with the prior VECU system on the 567, this will be very familiar. In general, all of our models will be using the same connectors, available in the same locations, and provide the same functions. When considering the chassis to body connections, you need to know what type of communication is needed. Will it be hardwired connections or CAN-based J1939 communication? J1939 is the language that is spoken over the CAN bus. Both are available and conveniently located with VMUX. Many times, body integrators need more detailed information on the specific pins and messages that are available. I always recommend viewing our online resources for the latest bodybuilder manuals and information. Let's look at some of the more common connectors that are used. This shows the 12-pin remote throttle connector, the 8-pin remote throttle preset speeds connector, and the J1939 CAN bus connectors. The 8-pin for remote preset speeds is only available with the MX engine and provides industry-leading customization. The picture shows a Model 567 with 3 locations where the connections can be spec'd for convenient body integration: in the engine bay, at back of cab, or at end of frame. However, these same options are now available in the exact same way for the rest of the Peterbilt models. This promotes consistency for body companies regardless of which Peterbilt truck comes through their facility. 2 additional notes I want to make. First, I highly recommend adding the 12-pin connector to the truck spec if there is any possibility that it may be needed. And second, talk with the body manufacturer to know if you should be speccing a 250 kilobaud or 500 kilobaud communication speed. We offer both options. However, body companies typically configure their components around one or the other. Another example is simple body lighting connections like stop, marker, clearance, and turn lights. The junction box that has been available for a long time is still an option on all models. I also want to highlight specifically for the new medium duty, since simple body lighting is so common, a 14-pin connector that is now available. It provides the same functionality as the junction box with improved sealing and is located behind the back cab crossmember. This is a very nice improvement for these applications. The Model 520 continues to include the refuse industry standard RP170 connector shown here. It's also worth mentioning that the PTO functions box that was previously available on the Model 520 is no longer needed. All the functionality that was provided in that option is now fully integrated into the 520 with the MX engine and VMUX electrical system. The last connector I want to highlight is the RP1226 connector that is commonly used for a variety of devices such as telematics, ELDs, and body controls. First, each of the truck models is now standard with this connector, and the heavy-duty models are now standard with 2 of them given their growing popularity. The new medium-duty models will have one, which is located near the OBD port on the left side. These offer the CAN bus communication that is needed for most aftermarket devices. Turning to VMUX switches, all the Peterbilt truck models with the VMUX electrical system will have the same multiplex switches. In the case of switches, the benefit of a common VMUX electrical system is that service shops and body integrators will be able to stock the same type of switch for all Peterbilt models. There are 2 basic types of switches: the multiplex, which sends electrical messages across the truck's CAN bus. Looking at the picture that shows the back of the dash panel, you see that these switches are daisy chained together for communication on the CAN bus. This reduces the size of wire harnesses behind the dash. The second type is a hybrid switch. It has the same daisy chained wire, however, that wire only supplies power to the switch for backlighting. The actual operating signal for a hybrid switch is handled using additional wired connections from the back of the switch to the function that it controls. I also want to highlight the switches can be moved to different locations on the dash, and in most cases, do not require additional programming. If you are adding or replacing a switch, the Davy programming tool will need to be used. There are also a number of other options for factory-installed spare switches. Electrical spares are available with or without wiring behind the dash. A new option being introduced with the new medium-duty models offers up to 5 switches with wiring that extends to the back of cab connector location on the chassis. This is very nice for aftermarket integration and eliminates the need to remove dash panels, so I certainly recommend you take advantage of this one. Next, we will take a look at some of the great features available with Peterbilt's new digital displays. On the left, the Model 567 and 389 have a 15-inch display. On the right, the new medium-duty models and the 520 have a 7-inch display surrounded by mechanical gauges. As you can see in these examples, both the 7-inch and 15-inch displays provide the driver an extraordinary amount of information in an incredibly easy to understand and consistent manner. To see more detail on all of the display features, visit Peterbilt's YouTube page. From a body integration perspective, one of the great benefits of the digital display has to do with editable telltales. These are icons or messages that can be illuminated using an input signal from the body. Up to 6 can be used on the 15-inch display and 5 on the 7-inch display. With these digital icons, you no longer need to insert physical telltale cards. All the available icons are on the display and are triggered using the same type of hardwired signal from the body. Simply plug into the telltale connector and use the DAVI and PVP programming tool to designate the icon that you want displayed. Audible warnings can also be triggered using a very similar method. Now, we will go over some of the important points of the chassis module and air solenoid banks. Electric over air means that electrical signals are used to control the air system. The primary changes from the prior VMUX system include multiplexed EOA activation, which replaces the previous air lines that were connected to the dash switches. A number of designs have been used in the past, and now all of these are multiplexed and common. Chassis modules also replace the old chassis node, and we'll discuss how that works. There are several components involved to actuate air solenoids, and they operate on the CAN bus electrical system. These are all shown on the right. An important point for body integrators: be familiar with the space claim for these components. They can move depending on the option content on the spec, and you want to make sure that every chassis layout works for the body installation. There are many benefits that come with the EOA technology, like built-in protections, which can prevent damage to the equipment. Being multiplex increases the reliability and functionality that can be offered. It also improves the ability for a technician to diagnose issues. Let's understand how the EOA system works. The blue lines here represent electrical signals, beginning at 1 o'clock. When the dash multiplex switch is activated, it sends a signal through the master switch module to the VECU, or Vehicle Electronic Control Unit. The VECU is the brains of the system. It receives all the incoming messages on the truck, comprehends them, and then determines where the signal needs to go. For example, if the request is for a suspension dump, the VECU will check the speed of the truck to ensure that it's okay to dump the air from the suspension bags. In the case of suspension dump, the signal is sent to the chassis module, which is part of the electrical system. The chassis module recognizes that signal to dump the rear air suspension and sends a signal to the correct solenoid on the solenoid bank. This is where the request transitions from electronic to mechanical. The correct solenoid then actuates, allowing the air to evacuate the suspension. Again, the 567 has been operating like this and offers many benefits. The 520 and 389 and medium duty will now function in the same way, so body integrators will have consistency. We'll cover this in more detail in another training module, but the main thing that I want you to take away is the importance of paying attention to where these components are located on your specific layout. In this section, we will introduce the topic of programmable settings. These are one of the valuable benefits that are capable with the VMUX system. They offer extensive configurability that can be spec'd with the truck or programmed later. Common settings are available with the factory spec. Many more settings for specific applications are available using the Davy and PVP programming tool. Here you see just a couple examples of settings that can be programmed to optimize the truck for specific applications. As I mentioned at the beginning, there are several important takeaways that you would learn from this overview. We have introduced a new VMUX electrical system across our model lines. Commonality of a single electrical system greatly simplifies body integration. A multiplex system improves reliability and diagnostics capability, maximizing uptime. Keeping the operator informed helps productivity and training. The VMUX system is customizable to fit each customer's specific application. And once again, I want to reiterate the importance of understanding the customer's needs. This will help you spec the truck correctly. It will lead to a better body integration and ultimately better performance when the truck is in service, all of which will contribute to the Peterbilt advantage. This module has just scratched the surface of information that you want and need to know. For more information, be sure to watch the additional Peterbilt body integration modules, which dive deeper into each of these important topics. Additionally, Peterbilt provides many other resources, including the Peterbilt.com website. When there, select Bodybuilder Resources from the drop-down menu. This will take you to a page where you can download the latest information and technical resources. Peterbilt's YouTube page. On the main page, go to the Bodybuilder Resources channel to find the latest videos. I recommend subscribing to this specific channel so that you receive updates when new information is posted. Next is the PeterbiltOneSource.com website where you can conveniently access sales materials. Also, PACCAR.net is an updated version of DealerNet. It is always a good place to find technical information during the speccing process. And finally, PACCARPowertrain.com has a lot of good information about the PACCAR powertrain. I hope you have enjoyed this introduction to Peterbilt's VMUX training, and I look forward to our next opportunity to work together. Thank you.